So over last weekend, we had a few nice days here, and I decided to, obviously feeling like not feeling like reading any kind of news source, go out to the electric grids in the United States and try to see how much renewable energy they're producing on these power grids. And of course, you got PJM here in the east, in the mid-Atlantic, where I'm at. You've got New England ISO, New England Independent System Operator up in New England, New York Independent System Operator, multiple others, ERCOT down in Texas, and then we got CA ISO, California ISO, ISO Independent System Operator in the state of California. And that was the most interesting, although all of them are interesting. But California ISO was generating 95% of its electricity demand from renewable energy sources, which in the state of California are considered to be solar, wind, geothermal, biomass, biogas, and small hydro. Large hydro is excluded from the definition, so is nuclear energy, of course. And 95% of that, and 85% of the 95% was coming from solar. It's pretty amazing. So when you look at, California ISO, California ISO does not cover the entire state of California. It covers most of California. So if California has a population of 38 million people, CAISO provides power to 30 million of those. So what's the other 8 million? All right, well, there's a few areas, Sacramento and Los Angeles are the big ones. LA, right? Los Angeles is not part of California ISO power grid. Los Angeles has its own power grid. The LADWP, the Department of Water and Power. So the DWP in Los Angeles operates completely independent of the rest of California's power grid. Now, that's not to say that they don't buy electricity from surrounding areas. They certainly do. But they're not dispatching generation, and their demand and everything is decoupled from what CAISO would be managing. So that leaves some interesting things to look into. So basically the title of the video here is LA, the city lit by direct current. And what do I mean by that? Does LA's power grid use DC instead of AC? Well, if you're in the city of Los Angeles, no. Electricity in Los Angeles is exactly the same as it is in Pennsylvania or anywhere else in California or in Canada or anywhere in North America for that matter. It's all the same thing. You plug your 120 volt, 60 hertz device into the wall and it works. But the key to the difference is, where does Los Angeles get its electricity? So LA Department of Water and Power, kind of over the decades, and I'm talking all the way back to like the 1930s, started to procure electricity from very remote locations. So the state of California, especially back in the, in those days, they didn't really have a lot of, the huge amount of natural resources, especially Southern California. You didn't really have the hydropower. You didn't have coal. California doesn't have a whole lot of coal. Oil was just starting to become a big industry there. Natural gas is a similar sort of situation. So it's like, where are we going to get electricity from for this burgeoning city of Los Angeles? And they, thought about it. I think they, some people were involved. And if you think about the 1930s, that was when the Hoover Dam was built. So the Hoover Dam was built in Nevada and Arizona on the Colorado River there. And Los Angeles Department of Water and Power was actually the operator of the generation powerhouse at Hoover Dam for a long period of time. And LADWP got into Hoover Dam, and they built power lines that ran from Hoover Dam to the city of Los Angeles. And much of the electrical output from Hoover Dam over, especially in the early days, went directly to Los Angeles. But then Los Angeles, LA, it got bigger, more people went there, it became a city, the second largest city in the United States, a lot of people, and so they needed more and more power. And one of the classic problems of Southern California is air pollution. So back in the 50s, 60s, 70s, 80s, and even 90s, air pollution was an incredibly massive concern in Southern California. So, are we going to ship in coal from the Midwest or from the Rocky Mountains or from somewhere inland and burn the coal in Southern California and add to this incredible air pollution problem when we don't have the technology to clean the emissions from the coal? No, they didn't want to do that. Why would you want to do that? They have a bad enough pollution problem already from cars and other industry and everything else. Why the hell would they build coal-fired power plants in Southern California? Some very brilliant people got together and said, okay, well, how about we build some power lines to bring electricity into California from somewhere else, into LA. And for whatever reason, this only really caught on for the LADWP region. So what we're talking about here is high voltage direct current. So Los Angeles has two major HVDC, high voltage direct current power lines that come into the city, into the LADWP utility region. So if you live in that area and you get a bill from LADWP for your electricity for your house or whatever, these power lines are likely involved with delivering some of that. So you got the Pacific intertie. That's this line right here, if you can hopefully see it. The Pacific intertie starts in Oregon and it goes all the way to Los Angeles. It travels a length of, how long is this thing? 500 miles? Do they tell us here? Pacific intertie is of course I'm gonna miss it. All right, well, I think it's about 500 or 600 miles that this line runs. Oh, no, 846 miles. So this power line runs from right at the border of Washington and Oregon to Silmar in California. 846 miles of power line. It goes through Nevada, then it goes through California. So the whole idea back in the day was, all right, well, they have a lot of hydropower up here. There's a lot of, the Columbia River is a major source of hydroelectric power, and we can take advantage of that because they don't need so much electricity up here, especially in the summertime. We need it down here in LA. So let's build a big giant power line to get it from there to here. 846 miles. Direct current. DC. So the DC power line is very, very distinguishable from an AC power line because there are only two wires. So here in the East, where I'm at, power lines always tend to have, they always have three wires, three phase, A, B, and C, three phase on them. So you got three conductors hanging from insulators coming from a power plant, out here the longest line, you know, your electricity goes like at most 50 miles at most before it gets to your house because the plants are so close to you. I mean, the closest power plant to my house right here is less than 3 miles away as the crow flies. Right? It's a wind farm up on the hill. Maybe 4 or 5. I don't know. It's very close. It's less than 10, I can tell you that. And we use AC to get it from there to here. But out there, when you're going 850 miles, it's actually more energy efficient and more cost effective to convert AC into DC and then convert back to AC at the load. Because you only have to run 2 cables because it's positive and negative instead of 3 phases. And you can transmit the same amount of power with the same size of cable with 2 wires instead of 3. And then these wires, the capacitance to ground is not a big deal because DC is a constant, you know, the voltage is not oscillating, so you don't have capacitance loss from the wire to the ground at high voltage. You don't have as much corona discharge on the wire, and you lose less energy on the transmission line. So the other advantage here is this line can actually operate if you were to have a tree or something contact one side of the wire. So you got your positive and you got your negative wires. There's also an earth return. So in California, they buried a whole bunch of electrodes in the ground. And then in Oregon, they did the same thing. So you can actually operate this power line in what they call monopolar, where if you lose one side, either the positive or the negative side of the system, the electricity can actually return through the earth. So it can go through the ground all the way from Oregon to California. In reduced power, of course, but you can still send watts through the wire. That's pretty impressive. A power line like this is a Pacific intertie. The voltage between the wire and the ground is 500,000 volts, DC, positive or negative, depending upon which side of the line you're on. But the voltage between the wires is 1,000,000 volts. Whereas on an AC power line, the highest that we have in the United States is 765,000 volts from phase to phase. So these lines are much higher voltage. So for a given power, your current's less loss, once again. So the Pacific intertie runs at about 1,000,000 volts, positive to negative, 500,000 plus or minus. And that supplies about, this line can transmit, what is it here? 3.1 gigawatts. So line capacity is 3,100 megawatts, which is enough to serve 2 to 3 million Los Angeles households and represents almost half of the LADWP's electrical system peak capacity from the Pacific intertie. Pacific intertie is bidirectional. It can send power both north and south. So they can go from California to Oregon, and they can go from Oregon to California. So depending upon the season, depending upon the time of day, electricity can go both ways. It's pretty versatile, right? So in the wintertime, I would expect California to actually be sending power to the Northwest because they need power for heating up here. Whereas down here, the climate's nice in the wintertime. You don't really need a lot of power for climate control. So you got the DC intertie, the Pacific DC intertie, also called Path 65, part of LA's direct current supply. Then we also have the Intermountain intertie, or the Intermountain Power, what's it really called? Intermountain Power Project. So the Intermountain Power Project is a little bit different, but it's the same kind of idea. So it's a large coal-fired power plant in Delta, Utah. It has a capacity of 1,900 megawatts, 1.9 gigawatts. and is operated by Los Angeles Department of Water and Power. So there's an HVDC converter station that takes electricity from the coal-fired power plant, converts it into DC, and ships it from Utah to Los Angeles. So the advantage of burning coal in Utah is you're outside of the Southern California air basin. So any of the emissions that are generated by that, so this plant was built in the 80s, in 1981. So any of the emissions generated by burning the fuel are outside of the air basin in California, so you don't have to worry about the pollution building up along the coast like it tends to do in LA. Now the Intermountain plant it's a pretty sophisticated, a pretty modern coal-fired facility. It has flue gas desulfurization, so they remove all the sulfur dioxide from the emissions before they send it up the stack. So the only real environmental byproduct from an air standpoint from this nowadays is the CO2 emissions. So you're burning a few million tons of coal a year, so you're making a lot of CO2 at this Intermountain plant. But LADWP decided back in the 80s that's what they wanted to do. It made sense at that time to burn the coal out of state, ship it over a line. So Path 27 is the name of the line, also known as Intermountain Power Line, DC Power Line. And it goes, how many miles is this one? So, are you going to tell me? Path 27. Right? How long is the Intermountain Path 27? Yes, so Path 27 is an HVDC line. It operates at plus or minus 500,000 volts, so it's the same voltage level as the Pacific intertie, and it can transmit a maximum of 2,400 megawatts. Goes through the Mojave Desert. Here it is. Likewise, there's 2 wires suspended by insulators. So that's how you know if you drive under this line, you look up and you say, oh, that's DC, that's direct current, because there's 2 conductors, not 3. And its length is 488 miles. So it's like half the length of about half the length of the Pacific intertie. The cat's going crazy. ABB from Switzerland built both lines. So the Los Angeles Department of Water and Power owns 60% of the capacity of this line. Here's the picture of the line as it comes into Interstate 15 in California. So there it is. 1 wire positive, 1 wire negative. Easy enough, right? You know, there's 2 wires. That's how you know it's DC. So you've got 3,100 megawatts, 3.1 plus 2.4, 5.5 gigawatts of capacity on 2 direct current lines for Los Angeles. So that comes out to about that's about what you need for a city of 4 million people, right? I know that not all of the capacity or not all of the electricity in LA is generated from these lines or supplied through these lines. They do have solar power in Los Angeles County. There is gas-fired power stations there. But it's a very unique place with regard to the fact that these direct current power lines provide such a large fraction of the electricity that they're using in Los Angeles in the LADWP system. So this looks like a map of kind of the western U.S. Electric system here, sort of block diagram. Of course, it's a JPEG, so it looks like crap. Yeah, LA, there's Path 46, or Path 27 from Utah. DC 65 is DC from Oregon. So that is the city lit by direct current. definitely unique in the United States. There's not too many places where we use HVDC sort of this way within the country. New England uses HVDC to import electricity from Quebec in Canada because Quebec is not synchronized with New England. So they have to convert to DC, transmit it over the wires, and then convert it back to AC and synchronize with New England. Texas does a little bit of back-to-back HVDC where they synchronize with the Eastern Interconnection with MISO and the other grids that are there and transmit power back and forth. Same with Mexico and Texas, DC, back-to-back. But the LA situation is certainly one of the bigger ones. And these inverters that they use, they started off using mercury arc rectifiers to convert the power from AC to DC, DC to AC. Now most of that's, pretty much all that's been converted over to semiconductor devices, thyristors, as they call them, to switch the power, convert back to AC, inverting it, as we would call it. So Intermountain, so even though California ISO doesn't have a lot of coal on it, they always say there's like 7 megawatts of coal, LA is still importing coal from Intermountain. So Intermountain, if it's operating at 100% capacity factor, is a 1.9 gigawatts or 1900 megawatts of coal-fired capacity, electricity generation. So that's it. Los Angeles, a city lit by DC, direct current. All right.